on the test in here?
I've had to go in there to get. I've had to go into the boys' room to get Gatorade for interviews, and it's like they're not good. That's for sure.
No, there's a reason they're not. Okay, so we know we've been using x squared plus y squared equals r squared over and over and over again, right? We know that comes from the Pythagorean theorem. We use it, that was rude, to find the r when we have an ordered pair. So I want to take this, if I took that and I divided everything by r squared. We know in an equation it's legal if you divide both sides by the same thing, right? X squared over r squared, that would be the same thing as x divided by r squared plus y divided by r squared. What's r squared divided by r squared?
1.
1. Okay. What is x over r? Cosine. Now, when you have a trig function squared, so we know that's cosine theta squared, you actually put the square on the word cosine. You don't want to put it after the theta because then it looks like your angle is squared. So that's just a notation thing. What is y divided by r?
Tangent. Yep, that's fine.
Okay. So this is a Pythagorean identity. Usually if I say it, I flip it around. It doesn't really matter. Sine squared theta plus cosine squared theta equals 1. We will use this a lot. Not really right now. This is just kind of the first time I'm showing it to you. But this is probably the single most important formula we will find in trig. So even if you take calculus or anything, I'm going to say what's the most important trig formula, and it's going to be this one that we use every single time. Sine squared plus cosine squared is going to equal 1. There are technically 3 Pythagorean identities. Right now, this is really the only one that I'm probably even going to ask you to use for quite some time. The others are just variations on it, so I'll go ahead and show them to you, but this is the one that I would want you to be able to use right now. And probably at this point, if I wanted you to use it on the test, I would probably say, use the identity sine squared theta plus cosine squared theta equals 1. So I really wouldn't even expect you to memorize it yet, just know how to use the formula. And I will show you how to do that here in a little bit. The next one, just kind of as a tidbit, we will see these in later chapters. They're all variations of the same. If you start with that, I got this formula by dividing by r squared. What else could I divide everything by?
X squared, y squared.
Yeah, x squared or y squared. That's going to give me the other 2 formulas. Okay, so if I do that, I get 1 plus, what is y over x?
Tangent.
So that's 1 plus tangent squared theta equals, what's r over x?
Cosine.
Is it?
No.
R over x, reciprocal of cosine is secant. So 1 plus tangent squared is equal to secant squared. The final one, if we divided everything by y squared, so we have x over y squared plus 1 equals r over y squared. What is x over y?
Cotangent.
What is r over y? So these are the 3 Pythagorean identities. At this point, they're all fair game. You're welcome to use any of them. But the only one that I would potentially ask you to use right now would probably be the first one. That's the most commonly used one. And we will see them again in greater detail later on. Any questions about where these identities came from? Okay. Second thing, I need everybody to make sure you're paying attention to me right now. Quotient identities. These are going to be extremely important. We will use them a lot. So we already know the reciprocals. If we have sine, that gives us cosecant. If we have cosine, we get secant. If we have tangent, we get cotangent because they are reciprocals. There's another relationship if we talk about quotients. So if I asked you, what is sine divided by cosine equal to? So let's think about our definitions. What is the definition of sine? What's the definition of cosine? How do we divide fractions? Flip and multiply. So those r's cancel. So we get y over x, which is so the quotient, we know tangent can also be found by doing sine divided by cosine. So if I did reciprocals, what would cotangent be equal to? Cosine over sine, because reciprocal just means you flip the fraction. So we flip them. Okay, so those are a couple other relationships that we can use.
Can we do that with all of our, like, can we do that with?
You could divide other two functions and see what you get. These are just the common ones. So really what I've given you right now is just a lot of tools for finding the same thing. You don't have to have the Pythagorean identities or the quotient identities to do any of your problems, but they can be helpful. And as we move forward, we will use them more and more often. So I just wanted to finish with an example or two, just to show you how you might use these. So in this one, I want cosine and tangent. And I'm going to tell you sine is negative radical 2 over 3 and cosine is greater than 0. Tell me one way I could do this. Well, if I know sine, what's the definition of sine? Y over r. So technically, I know my y and my r. Would the negative go with the y value or the r value? The y, because r has to be positive all the time. So could we do this the exact same way we did all of our problems yesterday? Absolutely, 100%. And if you do that, that's fine. I don't care. Can I show you another option?
Absolutely.
In case somebody likes this other option? If you don't have to use it. Okay? If I want cosine, I could use my Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Okay. Sine was negative radical 2 over 3. Negative radical 2 times negative radical 2 is positive 2. 3 times 3 is 9. What would you do now? 1 is like 9 over 9 minus 2 over 9, so that's 7 over 9. How do we get rid of a square? With the square root, we always do plus or minus. However, I told you that cosine was greater than 0, so I need the positive. So cosine is the square root of 7 over the square root of 9 is 3. How could I get tangent? We could go back to x, y, and r, or we can do sine divided by cosine. Both legal options. If I wanted to just show you how to use these identities. So sine radical 2 over 3 divided by radical 7 over 3. Okay. So we have to get rid of the fraction and the fraction. We have two options. We can flip or multiply, or we're going to encounter these things a lot in trig. Sometimes I tell people it's easier. You can multiply the top and bottom of the fraction by the same thing. What would I probably want to multiply by? If I take top and bottom both times 3, it gives me negative radical 2 over radical 7. Get the radical off the bottom. So negative radical 14 over 7. So is it faster? Probably not. If you only have to find one trig function, it might be faster to use identities. If you have to find multiple, it's probably going to be faster to do x, y, and r. But it's just another tool that you have and you can use. Do we need more examples with anything? So then you guys have time to work on your homework.
I have a pop on the news.
Absolutely.